Ja, liebe Kolleginnen und Kollegen,
Well, colleagues, ladies and gentlemen, it's such a great atmosphere here in Stuttgart. Welcome to our forum on artificial intelligence and intralogistics. So, learning what we don't understand, and we're going to tell you a bit more what we mean when we say that. And right at the very beginning, I would like to introduce the colleagues. I'm Michael ten Hompel. I'm the managing director of Fraunhofer Institute of Material Flow and Logistics, and I'm also Chair of Materials Handling and Warehousing at the Technical University of Dortmund. And with me I have Stefan Hohm, CDO of Taxa Group, and Henry Poole, CTO of Kion Group AG. So we have great people here, and they are going to tell us a bit about the use of artificial intelligence. I'm really looking forward to that. We're going to have short pitches, and I'm going to give an introduction on the topic first, and then we are going to have a discussion, the three of us. So if you have any questions, please ask. But first of all, we are going to get started in this topic. Logistic goes AI. So this is the topic of our Congress in Dortmund this year. And I don't think I have to tell anyone here that artificial intelligence and digitization is something that is going to change everything. So the world is, well, getting upside down regarding the things that artificial intelligence is going to do. And it's really enormous when we take a look at the speed that it's happening with. I'm going to come back to that in a minute. Well, first of all, I would like to show you one of the slides from my presentation on material flow, because I wanted to show to you what artificial intelligence actually is. And on that slide, we can see that artificial intelligence is actually a part of IT, informatics. And we often talk about machine learning, and then you can see all the buzzwords that you're all familiar with underneath. Machine learning, for example, neural networks, and so on. And this is usually assigned to machine learning. So what is artificial intelligence? Artificial intelligence is everything that we perceive as intelligent. This is a rather simple definition, but this is exactly what it is. And now we have to talk about what intelligence means. Well, actually, for that, we would need a whole lecture. So what is machine learning? And I think we can see that quite nicely. Machine learning is iterative learning of information, of data and their connection, maybe also sensor data, ambient data. And iterative means that it is self-optimized learning. So it's not programmed on a rule-based system, but the algorithms change their behavior. So artificial intelligence is not something that was just invented yesterday. In the 50s, actually, there was a Turing test. A colleague in the 50s has invented a test to see when a machine is really intelligent. So this test was invented. So a human being is standing in front of two rooms, locked rooms. In one there is a computer, and in the other is a human being. And when you talk to them, and the human being cannot distinguish in which room there is a computer and which the human being is. So this means that if the other person cannot distinguish, then the test has been conducted successfully. Okay, so we have a chess computer, like for example in the 80s, which was a rule-based system. So the real machine learning is something that was only invented in the years after 2000. Machine learning, as you might remember, for example, the Go world champion that was beaten in 2016 by a machine learning system. This created a lot of attention. Or the chess champion summit, a summit machine, IBM computer. So this was beaten by a computer, and the computer had only played against himself for 4 hours. 4 hours playing against itself, and then the computer beat the chess champion in 2018. So here you can see the speed of machine learning. So then we have a connection to the surroundings, the transfer of what it has learned. And that's precisely what we're seeing a lot here. And I'm going to give you a few examples to illustrate this. So for those of you who have maybe seen it in Dortmund, at the University of Bonn, we have set up a new institute with some professors, and we have just started that. We have 20 million subsidies per year. So with that, we can really go into the depths at the Lamar Institute for Machine Learning and Artificial Intelligence. So this is supported, as I said, by the federal state, and in the Lamar Institute, the idea is to include the surroundings. And this brings us to a couple of examples, and this has to do with the people that are next to me. So the first example is from DAXA, and Stefan Hohm is going to explain that in more detail in a minute. We have vision system, intelligent cameras, scanners that analyze the distribution center and figure out where the packages are. And with that, we can greatly increase transparency because we always know what is where. So this is one of the basics of logistics. And we have also applied for the German Logistics Award. So in the solution that we have just seen, where AI in the camera systems or in the computer system to which the cameras are connected to, we have these so-called vision systems. And this is about the detection of barcodes, the detection of geometries, and here it is about detection of tasks. So with that, we can automatically see what the order picker or the packaging person, what they have done, what sort of package they have packed, what's in them. So what about the label? Maybe it's already there, maybe not. So this is automatically analyzed and then entered into SAP. So this connection between man and machine, well, this is something that is often the basis for augmented reality systems. So you can say laser projection system, or some other means. For example, this person is using safety goggles, but not an augmented reality goggles. So you get the information with OpenAI. You can see that on the tablet. OpenAI is also an important buzzword. And I'm going to come back to that in a minute. But what we want to show here at the intralogistics trade fair LogiMAT, and what we all connect, is the intelligent swarm. So here we can see the load runner swarm. We have artificial intelligence connected to it. So on the left-hand side, what you can see is a simulation. So this is an NVIDIA simulation. And on the right-hand side, you can see the reality of a behavior that was trained in simulation. And I think this is highly fascinating, although because of physical laws, it happens that one of the glasses falls down. This is not fake, this is reality. So this is how we train our systems in simulation, and we then transfer that one-to-one. And what we can see here is EvoBot. This is another robot, and you can also find that on our booth. And what you can see on the right-hand side is less AI, but it is autonomous driving. So this is not really artificial intelligence, but on the left-hand side, what you see there is a simulation. And here you can see these vehicles, and in a swarm, they start to organize themselves. And you can see in the simulation that these vehicles, drive around in a bit of a chaotic way. So they are getting used to their surroundings. This is typical AI application. Neural networks are then transferred to the machine, and then it is able to find its way around. This might be a term that you're going to hear more often in the future because this connects to each other to form a continuum. So we have simulation data, we create simulation models. The simulation models are then being trained the way you've just seen it with EvoBot, and the trained data are then transferred to reality. And reality, this could be a PLC. And all of that is continuously connected, and with that we create our continuum. Well, dear colleagues, why has this become such a hype? So when we think about AI, we all think about ChatGPT, about this transformer model, the chatbots that is trained to give answers. But also their development is really fascinating. So once again, we have an exponential growth. And if we now take a look at ChatGPT, what really fascinated me when I created this slide is the speed with which there was the transition from ChatGPT 3.5 to 4. So this is so much further developed when we take a look at the transformer technology ahead of us. And we do not know the range of parameters. It's probably more than a billion compared to 175 in the 3.5 version. It's really enormous. Take a look at these models. So the computer power or computing power that is necessary to train that and run it, well, this is something that we only invented a while ago. This is Boolean law, the exponential development of computing power. But there is also exponential growth of the performance of AI programs such as ChatGPT. And one example of how performance has increased is something that you can see at the very bottom, which is the bar test. This is to successfully complete the exam to become a lawyer. So for 3.5, we were all really fascinated that this bar test was successfully concluded by ChatGPT, but it was among the 10% at the very bottom. And the version 4 is to the 10% of the best students. So this is really an enormous development in the course of just a few months. And I completely agree with Sam Altman, the CEO of OpenAI. He said that AI might lead to our death or to the end of the world. Please don't take it so seriously. But in the meantime, we're going to do great business. So I think the use of AI in intralogistics can be one of these businesses, but the development of AI, well, no company in Europe or in logistics is big enough and has enough power or resources to develop something like ChatGPT on their own. So we have to go together, and this is something that we mentioned last time we were here with the Open Logistics Foundation. Together with Stefan Hohm, I'm in the board of the Open Logistics Foundation, and we are convinced that these complex questions, in particular regarding the speed in which it is developing, we will only be able to handle that together and on the basis of open source. The Open Logistics Foundation is a foundation of German law. There are 4 companies that came together, so Dachse, Remus, Duisburg, Harbour and Schenker. And we have others that have joined us, also software companies that have realized that What's ahead of us regarding AI is something for which we need a common joint basis. We need open source systems that we can use as a basis in order to further develop our products. So this is also a topic for the future Congress on the 12th and 13th of September. So we will meet there again, and we are going to go into more depth together with the Institute. But now we are going to continue with Stefan Hurm, the CDO of DAXA Group. I have mentioned you a couple of times already, and I'm sure you're going to tell us the rest yourself, what you have at DAXA regarding AI. Thank you. Well, thank you. Ladies and gentlemen, it's a great pleasure to be able to be here today, going to a real trade fair, and it's a real pleasure for me to be able to stand in front of you, not just, talking to a camera without seeing any reactions of those listening. So for me, it's a great pleasure, and throughout the course of the day, I will really enjoy the trade fair. And for those of you who don't know what DAXA is, it's a logistics service provider, and I just come here from the Allgäu region, from Kempten. It's a family-owned business founded in 1930, and in 2022 won 8.1 billion turnover with 33,000 employees in total. And as we can see in this picture, we are mainly active on roads, highways, and in cities in Europe, but we also operate warehouses with 2.7 million spaces, with 400 cross-dock terminals, and of course, sea and air freight also plays an important role. I've been working for DAXA for 31 years. I started as a student in the dual studies, and I looked at the development of management system for 15 years. I was head of subsidiaries, and since 2015, I'm now back in Kempten in the Allgäu region. And this brings me to the DAXA Innovation Cosmos from 2016, where I have set up an area which is maybe a bit, well, surprising for the logistics field. It's a research and development department. We have started to set up the DAXA Innovation Cosmos, and I think in 2016, in a city distribution congress in Dortmund, I got to know Mr. Hompel, and I went to the Fraunhofer lab with you, and you showed me what great preconditions you have there, all the technologies, motivated scientists, and of course, enough space in order to conduct the first tests. And so in 2017, the two of us started a development partnership, DAXA Enterprise Lab, as it was called. And this is now in its 6th year, and we're here with a framework agreement. We focus on main topics, which we then deal with in a flexible manner. We take a look at problems in logistics and try to solve these problems together. Our Innovation Cosmos, the way you can see it here, of course, it consists of many internal divisions and business units, but also university startups and many other technology providers and the DAXA Enterprise Lab. So what I would like to tell you now is that, from my perspective, what's really important is that artificial intelligence, and this discipline is in a competence center called data science and machine learning. And the important point here is the character of a competence center. We have experts from the business, so they know about sales and marketing, also production. We also have mathematicians, so they are hardcore statistic experts. Also regarding algorithms, they have an in-depth knowledge. And on the other hand, we have the big world of tools and coding. And we are also using the cloud world with all its algorithms, which we can use for various applications. And in the competence center, we develop them further. And what we get out of that is data science. So this is where intelligence is being created. This is where the applications are being created, the things that we use in our everyday life. So a couple of years ago, we have developed the first forecast on how we as DAXA can take a look at the incoming delivery volume 3 or 4 months ahead. So we have trained the systems for a long time, and the incoming volume can now be forecast down to the last 2 or 3% as a tactical medium or means, so that the forwarding company does not only have their gut feeling, but has a real means to help them to make sure that they have the space available at hand. We take a look at the addresses with the help of AI. We take a look at the internet and take a look at where the recipient is. Are they entered into the trade register? What sort of properties do they have or characteristics? And then we decide whether it's a private customer or a business customer. This might sound rather trivial, but for the processes in a logistics company, it is highly important, because if we take the truck and move it to the recipient, the question is there a ramp? What sort of knowledge does the recipient have? Do we have to tell them up front? So these are all things that our customer doesn't tell us, and this is why with the help of artificial intelligence we have trained the machine in such a way that now automatically our TMS is able to take such a decision and can then set the parameters accordingly that the production process up to the recipient can be controlled via these features. The mega trends, of course, also apply to DAXA. For us, it is really difficult to find industrial employees to work in the cross-dock warehouses. Omnichannel, I mean, every customer would like to have as many sales channels open as possible that we should service. People tend to move into the cities. There is more and more traffic in the cities. We also focus a lot on e-mobility. So what about the charging infrastructure? Process optimization is something that is very important. In particular here at the trade fair, we have AGVs, we have automation. Everything that looks a bit like IoT has to be brought together. Supply chain visibility, so the whole chain needs to be transparent and also in real time. And at the end, we also have the digital twin. And this is our latest baby, the digital twin. And it helps us to cast a direct glance into the cross-dock warehouse and to control the processes. Here you can see the supply chain at the top. You can see the customer. You can see the different runs. You can see thousands of trucks that move around in Europe every day. Then we have the next cross-dock warehouse. Then they are broken down into smaller consignments and then put into trucks and sent to the recipient. So this is how it looks like. So this is probably 7:30 o'clock in one of these cross-dock warehouses. And here you can see that it's probably difficult to understand which pallet is where. Of course, we have a system. You can see the numbers. But actually, when a pallet is not on the place where it's supposed to be, well, then we really have a lot of work to do in order to be able to find the pallet again. No pallet is being lost usually, but at the right point in time, we have to have it in the right position. And this is why we have decided to create a digital twin. And what you can see here is this metamorphosis from the normal pallets down to the digital twin. And what we can see here is the view. And I think you can easily understand that such a technology helps the shift operator to get an overview in real time. But at the same time, with the help of a tablet, you can take a look at the number of the unit. It's a unique number, and then you can find in real time the location of the pallet. You can see a picture of the pallet and also the dimensions of the pallet. So these are basic data that are important for our algorithm, and this is really good basis for planning that. Okay, that was everything I wanted to say. It was a short presentation, and I'm looking forward to take a look at the transformation together with you, not just diesel engines to battery electric, but also from analog to digital. Thank you very much.
Yes, I already mentioned it before. Dr. Henry Pohl, who's the CTO of the Kion AG. And as we just noticed, we have known each other for quite a long time. What's new regarding AI at your company? Well, thanks, Michael, for having me here today. I didn't bring any presentation with me, so you just need to listen to me if you want to. I would like to start with a little story bringing me to France. A couple of days ago, Andreas Grinninger, my colleague, and I were in France, sitting in a restaurant, drinking a good glass of red wine, and just out of fun, he asked me, have you ever tried ChatGPT? And I said, no, I haven't. And he said, wait a minute. He said, write me a poem on Henry Poole, the sports guy. And within seconds, a poem was created, and I was so fascinated by this poem. First of all, how much information is available on a specific person on the internet, but that you put that into a poem with an iamb rhythm, that you have sports activities that were actually highlighted, and that it was a clear description of a person, and that within seconds, that was just impressive. And Michael, for this presentation, biological intelligence is still going to speak about artificial intelligence. I can't wait to see until AI speaks about biological intelligence. So I'm really happy to be here today, Michael. These are just introductory remarks. AI is the key to many questions that we're still dealing with today at our customer applications. And I would also like to describe a key event that took place 4 years ago. And it was so inspiring because we didn't have the solutions back then that we have today. And to me, it was a key experience because it convinced me of the fact that AI can be the key to many other problems. 4 years ago, I visited a customer and we had just installed an automated solution, a hybrid automated solution. So our vehicles were hybrid automated. Several trucks that were being used, several shelf lanes were automatically serviced. The planning was excellent, the installation at the customers was excellent, our software was parameterized for the application. We did the installation, commissioned everything and handed it over to the customer. 2 weeks later, the customer told us the technical availability is not where it's supposed to be. So we went to the warehouse again to check what happened. Many things, I want to describe 2 of them. The first thing that happened, in this system, people were still running around, and sometimes these people were located in between these shelves and talked to each other, and sometimes boxes were put into these lanes because people had put them there. And these lanes were very narrow, and the automated vehicles have a safety switch-off mechanism, and they just saw there's an object hindering me, and the vehicle just did an emergency switch-off until this object went away. People stopped talking, or the box was taken away by someone else. This caused the performance to drop. So what can AI do nowadays? A huge step is if the machine doesn't just detect that there's an object here, but what kind of object that is. And once the machine detects it's a box, and I can go by this box at a 10-centimeter distance, I don't lose out on productivity. But the decision the machine takes, whether this is a box or a person, that is artificial intelligence. Because only based on image detection, machines can be trained to respond to a certain situation. And 4 years ago, this wasn't possible. It is today. Second use case, people hand over boxes to the automated systems, and the boxes are sometimes not where they're supposed to be, or sometimes they're outside the box they're supposed to be in, or the field. An automated solution will not find the box in its precise location and just switches off because there is an error and the human needs to intervene. Artificial intelligence can resolve this nowadays. We heard it from Daxa beforehand. In an ideal case, the machines permanently pick up where boxes are located in a digital twin. If the machine can do that and the box that's supposed to be picked up is not there, then AI can tell the machine it's not located here, it's elsewhere, and humans don't need to intervene. These are just two examples to show you what we did 4 years ago in automation technology had its limitations. And the core idea of automation is that it needs a very stable, predictable system that doesn't permit any arbitrary reactions or changes. And like that, automation functions quite well. But if you have humans intervening, if things happen that are not planned, if it's a box there, a person there, or maybe a damage to a load container, many things can happen, then the automated solution has a problem. And then we have to use artificial intelligence or autonomous systems. So that was just in a nutshell why I believe that AI is an enabler for resolving these problems. We believe today that it's an evolution, and I would just like to describe it with 4 different steps or stages. First stage was yesterday. Of course, we still have vehicles driving around our shops, and that's going to stay that way. And the first stage is our assistance systems on these vehicles. So I have a biological intelligence on the machine taking the decisions, the human being, but the human being is assisted by assistance systems, guiding systems, occupational health systems, navigation systems, start protection when I drive through gates which are not high enough. So assistance systems on these machines that are getting more and more intelligent with image detection systems. That was yesterday. Today, automation, the second stage. I just described this. These are deterministic systems. I define specific routes, and usually I also have stochastic distributions of warehouse spots, but it's a deterministic system, so humans plan this layout, and within this layout, these automated systems need to move. It works fascinatingly efficiently if I have standardized load containers and there are no changes of the system. That's automation as we see it today. Trucks, forklifts, fully automated warehouse systems, that's more complex. Tonight is the third stage, because that's autonomous systems. This means that, for example, machines use image detection systems, have comprehensive sensors, and collect data, identify situations, and can take decisions. An example are autonomous picking systems. So machines that automatically follow a picking person, detect what they're doing, when they need to stop, and need to continue when they need to. Automatic shelves are detected, and a picking person is supported with these systems. Image detection detects whether a person is standing somewhere, whether we have a box sitting somewhere, and they take decisions based on that information. Or a load container is not there, and they take decisions on their own. Autonomous systems, robots, you can use many terms here. That's tonight, that's already existing. And tomorrow is what Professor Hompel already described, autonomous swarm systems. Not only the machine is able to take autonomous decisions, robotic decisions, but machines communicate with each other, and they are networked, connected, and take decisions together when they need to be taken. These are the 4 stages of assistance systems: automated systems, autonomous robotic applications on different systems, up to swarm intelligence. And that applies to machine systems, but it also applies to software solutions. And a swarm intelligence for software solutions means that they have various software elements taking over different tasks, but the software itself will be connected, interchanging data, and create more intelligence. Last point, Michael, and then I'm going to wind up, I promise. What kind of problems can be solved? Just to give you an example, a big topic for DAXA is loading and unloading of trailers. How do I load these? You still need a lot of understanding and intelligence for that. It's like a Tetris game in the container. Human beings are now taking care of that. They know how they can load stuff, what's heavy, what's lightweight, where do I have damaged goods, how do I have to put it into the container. And artificial intelligence cannot resolve this because I can teach it to do it based on image detection. Second point is picking, especially from load containers, picking out several objects and knowing how to grab the object, how I can put it back down. That is artificial intelligence based on image detection. Grip into the box. Commissioning, palletizing. How do I construct a pallet that is going to be lifted onto a truck? That's something AI can also resolve. And the last use case for the warehouse management system, the core issue is same-day delivery. If everyone does that, the customer enters their request one day, and on the same day it's available at his place. That's the big issue that needs to be resolved, the predictability. What requirement or what demand is created where and when. We'll have artificial intelligence using various data and having different search engines and planning tools to analyze this data, to the precise predictability, what will be needed when. That's a benefit of AI. How do I stock my inventory and to have same-day delivery? These are just a few examples. I'm a fan of artificial intelligence. I believe it is an element that will clearly make our efficient solutions more efficient and reliable. Michael, thank you very much. Henry, thanks so much. Stefan and myself, we just said it's very difficult to talk here along the line. Let's just stay here and keep up the discussion. That's nicer for the atmosphere as well. You mentioned a few examples that really fit quite well to the title of this forum, Learning What We Don't Understand. Of course, that's a bit odd if you think about it, but the serious background to it is that today we are able to resolve problems, or we define control tasks and have AI handle it, which 2 years ago were hardly possible. We have control algorithms, and we try to resolve certain issues when it's about replanning, about algorithms, swarms. And we just saw this helps us get through the door, but the algorithms have to be adapted permanently. They never really fit. But we can learn them. And you can't have closed algorithms. A mathematical formula for an ideal batch is not available. You only have numerical solutions, and the same applies to swarms. So we come up with new solutions, and now we can resolve problems we couldn't resolve before. And I was so fascinated when I heard you speaking about 98% of predictability accuracy in distribution centers. That would be kind of a match calculation. Can you just let me know, what is this referring to? Well, of course, we're not getting a 98% daily materials handling accuracy, but at the end of June, for example, when we prepare the fall business, then every branch thinks about what tonnage they have to reckon with per day on average, and we have a basic fleet that we have permanently available, and in the fall and in the spring we increase the stock by a certain percentage rate in order to ensure the optimal capacity of loading space for the units that will be called off. And that's why we refer to it as a tactical planning. It's not an operational planning, because for operational planning we have a so-called short distance algorithm. So it's a short distance algorithm, which also needs the dimensions of the goods. And the dimensions are now generated with real-time measurements once the goods come into a storage area. And this means that the algorithm for this Tetris game is much improved compared to previously. And the forecast always refers to 3 to 4 months. And here we have the input tonnage, 1,000 tons a day, 5,000 tons per day that get into per week, come into such a branch with a hit rate of 98%. That really deserves a round of applause. And it's not a rule-based system. These are neural networks that use different indicators or statistical data that is fed into them and then provide us with a result and a forecast. You just mentioned Tetris. How long have we been discussing this and thinking about how we can automatically load the trucks and have a dynamic calculation system behind it? But we need the right AGVs and robots to do that. What do you think? When will Kion be offering automated truck loading for Amazon with packages? What do you think? Michael, the solutions are already available. We have handed them over to customers, but these were customers in the US. And the US is always different because the trucks are side-loaded. And that's an easier problem to tackle than if you have rear-loading trucks. And then the load containers that we produced there were standardized load containers, and it's easier then. So we usually have an MVP, a minimum viable product, or certain applications where we can already do this. But if we, for example, load a truck from behind, and I'm not using pallets, but individual boxes that I load onto the truck, that's quite complex. And here we have external partners that we collaborate with. And this year we are planning to have a first customer handover or custom application. And these are customized solutions for specific customers. And next year we'll have wide-ranging solutions. That's one of the few issues where many companies are working on this. And we have many associations between companies trying to find solutions, and we will see solutions. At the end of my short introductory talk, I already mentioned this. You're not a member of the Logistics Foundation yet, of the Open Logistics Foundation. You're not a member yet. But I know that you are looking at open source issues as well. I hardly see any alternatives. If you look at antitrust law and have the information scientists that you want to attract, they want to have an open source application. They don't want to program the same interface for the 100th time. In this new form, they would like to collaborate. What is your take on that? How are you positioned here? Well, just as we heard it, I mean, we have lots of open source applications. And, well, we are a traditional mechanical engineering company. And for a few decades, we have been specializing in automation. But the traditional approach to develop things was always to have an ingenious idea, to protect that so no one else can actually use it. And from this protected invention, you can generate business. And this already changed and will undergo more dramatic changes with the new software coding mechanisms. And we just have to open up because we can't offer the capacity. We don't have the capability. We have to link up with other people. Otherwise, you're out of the game. And you no longer protect your stuff, you need to open up. And we're massively building up on that because we believe it's right, but also because we see that customers need that, because no solution is really a closed solution. Every customer needs different systems that need to be linked up to that. And if you have a proprietary solution, then you kind of come out of the game and you need to open up to new business.
And with that, I would like to say, I mean, this is a discussion that we are also having in our company. And I said, well, DAXA founded in 1930, a traditional company. And I would like to underline that our own developments always make sense, because this is precisely where we can make a difference, and this is where we're going to develop things ourselves. But if things are what we call a commodity, if they already exist, then it doesn't really make sense to reinvent the wheel all over again just to do it yourself. So it's really about doing the standard things and taking them off the shelf. And where you can really see a difference, this is where you have to invest your manpower. So we can also see international developments. The two of us, actually the three of us, we cooperate a lot with NVIDIA, with the camera system. So we have seen that there is a lot on the graphics chip at NVIDIA. So we have also seen this with EvoBot. So this is all done open source. GitLab, Gits on, well, I mean, this is the basic software. And it is so powerful. So this is something that you cannot, develop as a company on your own. Well, there are two things I would like to mention. Open source is important. I mean, speed is everything. So in the past, when you developed a machine, you took 3 years to do that, and now it has to be much shorter. So even though I wanted to do that, do everything myself, it would take too long. So we have rather short cycles to bring innovation. And the second point, Michael, you just mentioned it, in order to not make too much advertisement for NVIDIA, but this is really a huge step forward because the computing power that I have in this mini format and that I can then use and install on different devices, this is really a quantum leap forward because with that image data can be evaluated and processed. And this is a huge step forward. We are talking about software, but if we miniaturize computing power, so this decentral applications making steps forwards is a huge enabler. What I also find quite fascinating, I mean, both of you represent rather, well, conservative companies, and we know that you embark on your own path, software-wise, in particular DAXA, and to what extent this is being adapted. So what sort of opportunities do we have here? I mean, to really work and improve the everyday business. There is one question I need to ask, and I'm happy that nobody decided to ask this question to me. ChatGPT. I think many of you will be, many of us will be interested to know, is that on your radar? Do you see possible areas of use for these chatbots, these language transformers? Last week, I attended an event where a company used ChatGPT already in order to do low-code, no-code applications to develop an app. And on the one hand, as we have heard early on, is really something that is quite shocking if somebody just wants to have an app and ChatGPT tries to find the different elements online and brings them together. I believe for us, I mean, we have a rather conservative approach. For us, it is rather an option to take information in the intranet range and make our employees aware of that. I think this could be a great application to take internal knowledge and tell employees about it. So these are the ideas that we are thinking about at the moment. You know, for production processes control, I think it is too early. So I would say that in our internal tech community at Kion, we are quite astonished. So we might have to think about an application because at the moment we don't see any. So we are quite looking at it in awe. So as I always say, I'm happy if people don't ask the question to me. So some actually do use it to, you know, prepare their speech. So I don't think that ChatGPT is the answer, but to show you another area of use. So we offer services, you know, and we all know that there is a shortage of skilled personnel. So how can we, for example, support the service technicians to get context-related information? Would that be a possibility to use such an application that asks the service technician, I have this or that mistake or error or fault, what can I do? So I think this is possible. Whether it's going to be ChatGPT, I don't know. But this is something that's possible. And something that's underestimated with a ChatGPT is how long it takes to get it up and running and train it. So it needs lots of parameters. but there are also open source solutions for specific areas of use. So how can we use, I don't know how many gigabyte on a computer and train it? And I believe that these could be areas of use. So many of that is open source. So let's work on the future together. With that, I would like to thank you. It was a great pleasure. I hope you enjoyed it as well. And I can see the red sign. We are actually a minute late. So thank you very much for your participation, for your attention. And I hope we meet again on our specific or respective booths and maybe tonight as well. So all the best to you.